Hello, my name is Mohammed Abdurrahman, and I'm an engineering student at University of Houston. Today I'm going to introduce the NAE Grand Challenge my partner and I chose to take on, giving access to clean water. We'll go into detail about the presentation as I go on. What are the NAE Grand Challenges? According to the NAE website, the NAE Committee on Engineering's Grand Challenges identified 14 grand challenges and opportunities for engineering during the world's next few generations. It pointed to engineering or scientific research and innovation that looked promising for addressing each challenge, as well as suggested currently unmet research needs. The challenges are: make solar energy economical, manage the nitrogen cycle, advance health informatics, prevent nuclear terror, advance personalized learning, provide energy from fusion, provide access to clean water, engineer better medicines, secure cyberspace, engineer the tools of scientific discovery, develop carbon sequestration methods, restore and improve urban infrastructure, reverse engineer the brain, and enhance virtual reality. Before we go on to our topic and present you the code, let's just put things in perspective. Imagine you just came from your daily 3-mile jog and you're really thirsty. Without even thinking about it, you reach for the tap, you grab a glass first, you reach for the tap, and you grab some ice cool water. Afterwards, you go take a shower and you go on with your day. Now think about on that same day, a mother in Somalia had to walk 5 to 9 miles to and back just to get water at a river. And when she reached to the river, she could not drink. She had to carry the water back and boil the water before she could even drink it, losing some in the process. Countries like Sudan, Ethiopia, Somalia, Kenya, Eritrea, Tanzania, Mozambique, and Angola are just a few countries that are at risk or in drought recently. Problems arise such as contamination, pollution, supply shortage, and it's leading to droughts. And it's also leading to famines. No water usually leads to no food. This challenge pushes engineers to find ways to make water cleaner, or at least pushes engineers to make it easier to access clean water, like it is here. Our goal is to help create a code that would highlight a specific region in Africa and show how many people have access to clean water and access to just drinkable water. And if these regions are on par or above with sanitation targets. According to Al Jazeera News, more than 6.2 million people in need of urgent humanitarian aid, including nearly 3 million people who are going hungry. That's just on Somalia's 2017's drought. Mind you, people, we're just hitting April. As we take a look in our algorithm, you already noticed that we have your housekeeping commands, CLC and clear. We defined our variables. We loaded the data set that we manipulated from UNICEF's data into our CSV. We created a matrix. And then we created a menu asking the user to select what region in Africa: northern, southern, eastern, western, and central. By asking this, a loop is created to show what part of the region, what part has the urban population, the rural population, what part of the total population, what parts of the total population that has access to clean water, what part of the population that does not, and what part has access to sanitary water to bathe. We used while loops when we were trying to make sure that the user input of sanitation target was in between 50 and 100, and the program will continue to ask the user until the number fits its range. We use the for loop to ensure that the data given to us did not have any negative numbers, as it's impossible to have a negative population. And then we finally outputted FRF statements to present the population in a more nicer way to look at. Also, we decided to make a bar graph making it easier for the user to see whether or not if the region is meeting sanitation targets. Now, as we take a look, here is the code. We have the housekeeping commands. Our variables are MDG water, MDG sanitation level, and our selection. We did data validation, and doing that we used our while loops. We had 2 while loops actually. The first while loop pretty much made sure that the rows which contained the regions did not go over the 5 regions stated before. We also had another while loop used as a control. Using this while loop, we decided to make sure if the user wanted to look up another part of the region, they could do so without having to run the entire program just all over again. When the program runs, it will output a bar graph. As such, we will now pick a region. For demonstration purposes, I will show you all 5, starting with the eastern. The program will ask what sanitation target is wanted. I will type in at first -40. It'll ask again. Then I'll type in 120. It'll ask one more time. Then I will finally enter a number in between. For example, 78. After you type in that number, a bar graph will appear and also a menu that will ask if you want to look up another region. For this sake, we will press yes, but not until we look inside the code. So the program outputted the first search, since this was the first time we looked up a region actually. It'll list the region shown, the urban, rural, and total, the urban population with improved systems, the rural populations with improved systems, and those 2 same populations with unimproved systems. It'll also show the drinking water coverage percentage, and it'll also determine if the water coverage levels are low. The water coverage level should be at 78%. It is below. The drinking water sanitation is supposed to be at the user inputted target. If it is below that user inputted target, it will show that it is below the expected target. So we'll now look up the western region. The western region will show after we show the target. So we're just going to use the same number, 78. Once again, shows the same thing using the different values. We will look up another region, the southern. 78. And once again, same thing. This continues until you realize in the northern region, they are actually supposed to be on track. As you can see, their drinking water coverage percentage is very good at 92%, and their drinking water sanitation is at 90%, way above that 78%. While this program is good, it does have limitations. Not much can be done besides highlighting the regions, and it can only express where uh, where the engineers need to focus. We hope that this program could be used by engineers that can push on and focus on where they need to go and help out these regions by giving them obtainable water and easier ways to drinking water. Water just to use to bathe. Just clean water. With me now is a promising student from UH. Hi, what's your name, sir?
Hey, my name is Ryan.
Nice to meet you, Ryan. Now, now that I've shown you this code, Northern Africa is actually the most well off of the regions of the continent of Africa that has the best drinking water coverage percentage and drinking water sanitation. Would you care to guess which one has the worst?
Sure, so I'd guess the western region of Africa, just because it's along the equator, so I'd imagine it'd be more difficult for them to have clean water.
Okay. Well, actually, you're wrong. If we run the code, Eastern Africa actually has the worst of all regions of Africa of drinking water coverage at 55 and drinking water sanitation at 25. Both are not on track to reach the sanitation levels and drinking water coverage levels given by UNICEF. Interesting, huh?
Interesting, yeah.
Yeah. Thank you for your time, sir.
No problem.
We hope that you enjoyed this presentation. We also hope that future engineers and fellow engineering students, such as myself and my partner, are pushed and encouraged and want to help. Because as we all know, we're not here for a long time, so why not make the best of it and provide for our future? Thank you.